Every night, in millions of homes around the world, something happens that we've almost stopped noticing. A dog curls up on the floor, breathing slows, eyes fall shut, and then, 20 minutes later, the paws begin to twitch. A muffled bark escapes. The tail flicks against the carpet, as if chasing something only the sleeping mind can see. We call it dreaming, and we smile, and we go back to whatever we were doing. But what if that twitching paw is the visible edge of something far stranger? What if behind those closed eyelids, an entire world is unfolding? A world built from smells we cannot imagine, memories we were never meant to witness, and a version of reality shaped by a mind fundamentally unlike our own. Because here is the unsettling truth scientists have only recently begun to uncover. Dogs almost certainly do dream, and the closer researchers look, the less that dream resembles anything we'd expect. For decades, this question sat outside the reach of serious science. You cannot ask a dog what it saw in its sleep. You cannot hand it a notepad. For a long time, that silence was mistaken for absence, as if without language, there could be no inner experience worth investigating. Then came the sleep labs, the electrodes, the brain scanners built for rodents, later adapted for canine subjects, who, remarkably, were willing to nap inside a machine for a treat. And what researchers found changed everything. Dogs cycle through the same basic sleep architecture we do, slow wave sleep, where the body repairs itself, and REM sleep, rapid eye movement, the stage in humans most closely tied to vivid, narrative dreaming. During REM, a dog's eyes dart beneath closed lids. Breathing becomes irregular. The brain, watched on an EEG, lights up in patterns that look remarkably similar to waking activity. In other words, somewhere in there, the lights are on. But knowing the lights are on isn't the same as knowing what they're illuminating. So scientists went further. In one of the studies that changed how researchers think about this entire field, neuroscientist Matthew Wilson at MIT wasn't studying dogs at all, he was studying rats. He recorded the exact firing pattern of neurons in a rat's hippocampus as it ran a maze, learning the route turn by turn. Then he recorded that same rat's brain during sleep. The pattern reappeared, not similar, nearly identical. The rat's brain was replaying the maze, turn by turn, at the same relative speed as if the animal were running it again in its mind. If a rat's brain can replay a physical memory with that kind of precision, it raises an almost impossible question. What is a dog's brain replaying on a nervous system vastly more complex than a rodent's, built specifically for social bonding, scent tracking, and emotional memory? This is where it gets strange, because a dog's brain isn't a smaller version of ours with the volume turned down. It's a different instrument entirely, one tuned to a different channel of reality. Roughly a third of a dog's brain is devoted to processing scent. Humans have about 6 million scent receptors. Dogs have anywhere from 200 million to over 300 million, depending on the breed. Structurally, the region of the canine brain devoted to analyzing odor is proportionally 40 times larger than our own. Which means that if dogs do dream in something like scenes, those scenes may not be visual the way ours are.
They may be built primarily from smell, layered, textured, almost architectural. Imagine a memory not as a picture, but as a scentscape, thick with information no human nose could ever decode. Try to imagine that for a moment. Not remembering what a place looked like, remembering what it smelled like, in such overwhelming detail that the smell alone reconstructs the entire scene. We simply don't have the sensory vocabulary to know what that experience is like from the inside. And that might be one of the deepest mysteries in this entire field. Not whether dogs dream, but what medium those dreams are made of. And scent may not be alone in shaping these hidden landscapes. A dog's hearing range extends far beyond ours, into frequencies humans will never consciously register. Some researchers studying auditory processing in canines have noted that dogs retain strong memory associations with specific sounds, a particular engine, a particular whistle, the cadence of a specific person's footsteps. If scent forms the architecture of a dream, sound may form its soundtrack, layered underneath in frequencies we couldn't even begin to reconstruct if we tried. A dog's dream, in other words, may be less like watching a film and more like standing inside an immersive environment built from senses we barely use at all. There's a reason many dog owners recognize this next detail instantly. Puppies and elderly dogs seem to twitch and vocalize in their sleep more than dogs in their prime. Researchers studying REM patterns across the canine lifespan have found exactly that. Sleep-related movement appears to peak early and late in life.
One leading explanation ties back to memory consolidation. Young brains are encoding enormous amounts of new information about the world, and older brains may be replaying a lifetime of it. If you've ever watched an old dog's paws twitch by the fire and felt for just a second like you were watching them relive something, that instinct may be closer to the truth than you realized. Interestingly, this pattern doesn't appear identical across every breed. Some researchers have observed that breeds developed for highly repetitive, high-focus tasks, herding breeds, scent hounds, working dogs bred for generations to perform the same sequences of behavior, appear anecdotally to show more frequent and more physically expressive REM activity than breeds selected primarily for companionship. This hasn't been proven as a hard rule across controlled studies, and breed-specific dream research is still thin, but it raises a tantalizing possibility that the content of a dog's dream may be shaped not just by its individual life, but by tens of thousands of years of selective breeding, that a border collie sleeping mind and a bulldog sleeping mind might in some subtle way be running fundamentally different software. This is a good place to pause, because if any of this is resonating with you, if you've caught yourself watching your own dog twitch and wondering what world they were standing in, this channel exists entirely for questions like this one. Every documentary here goes looking for the science hiding inside the ordinary moments of a dog's life. Subscribing means you won't miss the next mystery, and there are several still ahead in this one. Now, back into the dark, because dreaming isn't only about replaying the past.
In humans, dreams often bend memory into something new, mixing people, places, and emotions that never actually occurred together. Does a dog's dreaming mind do the same? Does a dog ever dream something that never happened at all? Here, science runs out of certainty and hands the question to hypothesis. Some researchers, including Wilson, have speculated that if the neural replay mechanism is similar enough across mammals, some degree of recombination, the blending of memories into novel scenarios, could theoretically occur in dogs too. But this remains unproven. It's plausible. It is not established fact. And that distinction matters enormously, because it would be easy to slip from a dog might dream something new into a dog has an imagination like ours, and that leap isn't one the evidence currently supports. What we can say with more confidence is emotional. Dogs and humans share deep evolutionary roots in the limbic system, the part of the brain responsible for fear, pleasure, attachment, and threat response. This system predates the split between our species by tens of millions of years. It's older than language, older than tool use, older than almost anything that makes us feel uniquely human. Which means the fear response rippling through a sleeping dog's brain during a nightmare-like twitch and the fear response rippling through yours during your own likely share the same ancient neuromachinery. Not identical, not equivalent in complexity, but built from the same evolutionary blueprint. There's something almost humbling in that. Long before either of us had words for what we felt, something in us was already afraid, already attached, already capable of longing for another creature's presence. Dogs carry that same inheritance.
So, in some sense, do we? It's worth remembering, too, where that inheritance comes from. Wolves, the ancestors from which every dog descends, also show REM sleep and similar twitching behavior in captivity, though far less research has been done on their dream architecture specifically. What domestication seems to have changed isn't the mechanics of sleep itself, but the content available to fill it. A wolf's waking life revolves around territory, pack hierarchy, and hunting. A dog's waking life, shaped by thousands of years living alongside humans, revolves around something wolves never evolved for: us. Our faces, our voices, our routines, which means that somewhere in the transition from wolf to dog, the raw dreaming machinery stayed the same, but what it had to dream about changed completely. Every dog sleeping on a couch tonight is running an ancient wolf's neural hardware on entirely new, human-shaped software. So what does a dog actually dream about? The honest answer researchers give is layered, not singular. Likely candidates include chasing. The motor patterns associated with running and pursuit are among the most commonly observed twitches during REM. Likely candidates include us. Studies on attachment suggest dogs form neural associations with their owners' faces, voices, and scent so strong that those cues activate reward circuitry even in the absence of the person. And likely candidates include fear. The same circuitry that lets a dog dream of chasing a squirrel through a sunlit field may, on a different night, replay the moment a car door slammed too loud. We may never get final proof of any single dream's content. A dog cannot describe what it saw, but the architecture is there. The neurons fire in patterns that echo waking life. The eyes move as if tracking something. The body remembers what the mind is replaying. Somewhere between certainty and mystery lies the truth. Dogs almost certainly experience something during sleep. Something built from scent instead of sight, layered with sound and frequencies we cannot hear, running on neural hardware inherited from an animal that once hunted in the snow. Something rooted in memory, emotion, and the deep evolutionary machinery we happen to share with them. And maybe that's the most remarkable part of all. Not that dogs dream, but that for thousands of years, this entire hidden world was happening right beside us, on the living room floor, in the quiet hours we mistook for stillness. If a sleeping mind can hold on to that much of the world, enough to replay it, enough to fear it, enough to twitch at the memory of it, it raises another question entirely, one that has nothing to do with sleep at all, and everything to do with what a dog remembers the moment they open their eyes, look up at you, and somehow already know exactly who you are. That's where we go next.